Hey everyone.
Hey, Mackenzie, how you doing?
Hello.
Good. How are you?
Hello.
Doing fantastic. Thank you. How are
So,
you?
I'm good. Good. Hanging in there, you know.
Awesome.
All right. So I actually put the PowerPoint slides for today's session in Nearpod. So I'm going to drop that link for everybody to access so that we can all share out and collaborate. Let me get that up.
Sounds good. We got a nice little crowd already. Some folks were writing to say that they weren't able to download the SamSpace app or they didn't have the supplies. And I was like, just come. All you have to do is just come. We're going to still, go through the projects with you and also send you the video later so you can always follow along later if you don't have everything worked out yet.
Yeah, no worries at all. I'm going to share my screen as well. So if you are somebody who didn't get to download the app, no worries. If you drop it in the chat and let me know, I can write a little list down because you can control my screen through Zoom, which is a pretty cool feature.
Nice.
All right, I'm dropping the Nearpod link. If you click on that and log in with your first name, it'll bring you to the slides for today's session. Or you can go to, if the link isn't working, sometimes it doesn't, go to nearpod.com and you can log in as a student with this code.
Yep, it looks like it's working for me. Yep, worked for me.
Awesome. I see we have some Nearpod fans.
All right.
I love Nearpod. If you haven't used it before, it's basically just a learning management platform that allows kids just to share out. And there's some games I have planned, like a little matching game and some questions along the way, just to make sure everybody is following along. Marlon, if that's okay, can I introduce myself very quickly?
Of course.
Okay. Hi, guys. My name is Mackenzie. I am an education consultant with Sam Labs based in Philadelphia. I'm a former teacher myself, and I taught all over the East Coast in New York City, in Washington, D.C., and also in Philadelphia. And I taught everything from 6th grade to 3rd grade. So I'm super excited. I was very passionate about STEM education, project-based learning in my classroom. And I'm super excited to be leading the session today with everybody here. So we're going to get started in just a minute. I want to make sure that everybody gets a chance to log in, and I know that people may have just joined. So if you just joined, welcome. I'm going to drop the link one more time. If you click that link and log in with your first name, it'll bring you to the slides for today's session. And it should bring you to our home screen, which is blasting off into STEAM. And that's going to be the theme for today's session. All right. I see that we have a lot of people logged in. There's about 7 of us logged in. And we'll get started in just a minute.
Yeah, you've got a good crowd. You've got about 15 people so far. We normally average around 20, sometimes 25.
Awesome. Welcome, everyone. All right. So while everybody is logging in and getting set up, just a couple materials if you have them. So today's theme is all about space and Earth space. I thought that it was relevant with the recent SpaceX launch. So we are going to be coding a system for a rocket within SamSpace. I'll be doing it with my blocks here, but no worries because of the way that our software is set up, you'll be able to code along with me. And then I have a little hands-on activity where we'll actually build our own rockets and get a chance to do our own little rocket launch. Marlon, do you think that we're good to get started, or do you want me to wait a few more minutes?
Yeah, definitely. Go ahead and get started. We are ready to go. We're right at about our 20 max. We're at 19 right now, so go for it.
All right, awesome. So one more time before I get started, I'm going to drop the Nearpod link in there so that you can share out and play our matching game later on. But with that being said, let's jump right into it. So I wanted to get started. I really always like to go over how to set up the screen. If you did get a chance to download the Sam Space app, if you didn't, no worries, because I will share my screen. But here is kind of like an overview of how you can have everything set up. So, and I'll share my screen for those of you that aren't logged into the Nearpod. There we go. So in the top right corner, having Zoom open so that you can see me, because I will be building with these Bluetooth blocks so you can kind of watch the code come to life. In the bottom right-hand corner, having the Nearpod open, the steps will be there, also some activities. And then in the left-hand side, if you did get a chance to have Sam Space, go ahead and open that up, and you're going to be coding along with me. And if you are on an iPad, yeah, you'll have to watch. I'll share my screen with you, and hopefully you can just follow along through Zoom, because unfortunately you can't split the screens on an iPad, but no worries. Let's get started with a little activity here. And we're going to be kind of framing our thoughts around Earth space science, okay? So this blast off into STEAM is going to cover all aspects of science, technology, engineering, art, and math. We're going to be kind of relying on all those different subject areas to kind of build our project today, which is ultimately going to be our very own rocket launch. So to get us thinking in this Earth space frame of mind, how far away is the sun from Earth? And on the next page in our Nearpod, I'm going to stop sharing, you're going to be able to see two answer choices. I see somebody already answered in the chat. I love it. And go ahead and take 30 seconds here to take a guess, an estimated guess. Maybe you do know the answer. How far away is the sun from Earth? Awesome. About half of us have already submitted. Looking good. Take about 10 more seconds. All right, final 5 seconds. I see students are entering in the chat. I love it. If you're not in Nearpod, no worries. That works as well. All right, and final couple seconds here. And I'm going to share out the results. Awesome job. Looks like we have Earth space science experts in this crew. So the correct answer was about 94,000 miles away from Earth. And everybody got that, so nice job. So let's jump right into then relating this to the SpaceX launch. Did anybody get a chance to watch the recent SpaceX launch? I know everybody is mostly in Florida, right? Yes. And so I don't know about you, but I thought it was really amazing. And so very quickly, if anybody would like to kind of think about this SpaceX launch, and the SpaceX launch was launched by Elon Musk's company back in 2002. But does anybody want to share out why this particular launch of the Falcon 9 was really important? What made the most recent SpaceX launch pretty important? Does anybody know? And you can feel free to unmute yourselves or just drop it in the chat. So I see one person shared out was that the drone landing on the engines. That was definitely a new feature. If we think back to rockets and spaceships, early on in American history, drones were not as prevalent as they are nowadays. But yeah, so somebody said it was the first one in the United States, first one on American soil in a long time. And that's exactly correct, because it's been over a decade where America has actually launched their very own rocket with American astronauts. And so it was a pretty big feat that SpaceX pulled off. And we know that, you know, behind SpaceX is Elon Musk. And I'm sure many of you are familiar with him. But, you know, who at the basis of SpaceX is so successful in making these rockets? Who, you know, like if we think to on the ground, you know, what and who is making the SpaceX so successful? Coders. Yeah, so I see coders, engineers, exactly. So that's what we want to talk about today. Has anybody ever wanted to kind of go in a rocket, maybe become an astronaut themselves, or just in general want to go up in a spaceship into space someday? I know I have. Yeah, great. So I don't know if you knew this, but actually SpaceX's goal and Elon Musk's in particular, this is kind of the reasoning behind why he wanted to find SpaceX, is that he actually wants to take civilians, so normal people, into space by 2024. So that means rather than just getting a flight ticket and hopping on a plane, that he envisions that you could actually hop on a spaceship and go into space by 2024. So I know some of you are saying no. I see others are saying yes, but that's only 4 years away. So there's a lot of work to be done by these engineers kind of to make this happen for the world of space launching and kind of rockets, right? So that's what I wanted to talk to you about today. And particularly, I wanted to talk to you quickly kind of about those people who are on the ground making this happen, right? Those engineers. So very quickly, I don't know if you are familiar with this. Who here is familiar with what an engineer actually does as a job and kind of what they're responsible for? Awesome. I'm seeing some yeses. I'm seeing some yeses. Okay. I don't know if you knew this, but there's actually 9 types of engineers that work for SpaceX. And so they're engineers that are very, very specialized in what they do. And for example, there's a launch engineer. So those are engineers that are solely responsible for understanding how that rocket ship is going to take off and take off safely. There's a structure engineer. So that's actually the engineers behind building the rocket ships with the different materials and making sure that everything is functioning and manufactured correctly. There's propulsion engineer. So ensuring that when the rocket ship takes off, that it is taking off in the correct direction and bringing in a lot of different physics into that as well, right? And so, you know, SpaceX engineers do everything from designing to manufacturing to testing, launching the rockets, and then even some coding behind the systems of the rockets. And so I see a question in here. Can you talk about all of them with more detail? So basically the little overall example is just within their names and their specialties, right? So the launching engineers are in charge of the actual launch, ensuring that it's done safely and effectively to get the rocket off. There's the structure, as I mentioned, you know, going into the manufacturing and building all of the parts and the different systems within the rocket, and the propulsion engineer. And so all of these engineers kind of work together and work alongside each other to ultimately, you know, manufacture the rocket ships, but then also test them and ensure that everything runs smoothly before we put astronauts or humans in the rockets. So I wanted to kind of give you a chance before I shared out a little bit more about how we're going to kind of step into this engineering role today. I want to give you a chance just to share out, you know, and think about what skills do you need to become an engineer. I'm not sure if those of you in the audience want to be engineers, but I know we have some here today that know a little bit about engineers in general. So I'm going to give you a chance here to share out. And so on this next page, it's loading. Let me start the activity. You're going to see an open-ended question, and it's just simply, you know, what skill sets, what kind of training do engineers need, or would you need to become an engineer? And go ahead and take a minute and a half here just to type out your response, and then we'll brainstorm together. Awesome. So I'm seeing some awesome, thoughtful responses come in here. I'm also seeing some thoughtful responses in the chat. Engineers need a great math base. They need to have a growth mindset. I love that. Math is was one of my favorite subjects to teach as a teacher, but also to learn as a student. So I'm glad to hear that we have a lot of mathematicians in here. All right, so apart from math, what other skills do engineers need? You have about 20 seconds here. Ooh, I love it. So creative thinking, coding skills, imagination. Awesome. And I'm going to share a couple more out here from the Nearpod. So this person shared that they need the math skills, like some of you mentioned, spatial skills. Does anybody know what spatial skills are? And if you share this out, can you explain exactly what spatial skills are? All right, no worries. So spatial skills are really being, yeah, I like that actually, knowing how to think in a 3D space. So knowing how to kind of think of objects and manipulate them within your mind before actually seeing them and bringing them to life. Critical thinking skills and problem solving skills, most definitely. So being able to look at a problem, understand that problem deeply, and then come up with different solutions to the problem. And then ultimately say, okay, this solution's better because the X, Y, and Z, and kind of rule out different solutions and make it the most effective solution. I love it. Let me find a couple more share outs here. This one kind of, knowledge about how to build structures. So really kind of getting into that, hands-on aspect of building and engineering. A lot of physics, especially for rocket scientists and engineers working with SpaceX, most definitely. I like this one. I would need to be able to use common sense and be able to understand math. They need to have positive attitudes so that when things don't work out, they keep going. And I love that. It's all about the perseverance, right? Things aren't going to work out, and especially with engineers. And in a second, we're going to talk about the design process. Things are going to go wrong whenever they're building and they're tinkering and they're trying to design. And when that happens, we need to have a positive attitude. We need to solve the problem in a different way. We need to come up with a different solution. So I love that. Awesome, guys. Thank you so much for sharing out. I saw a couple other answers here regarding backgrounds in sciences in general, but then also backgrounds in math. And so the reason why I wanted to talk about engineers is because they really rely on all aspects of STEAM, like the science side, technology, obviously the engineering, the art, and the math, right? All of those things come together into one kind of, you need to be kind of well-rounded in all of those different areas and subjects in order to really, find success as an engineer. So one thing that engineers are always thinking about and thinking through is thinking through this engineering design process. Give me a yes in the chat if you have heard of the design process before. Yes. Okay. Thanks, Noah. Thanks, Denise. Awesome. So a lot of us are familiar with the design process, and that's great. I actually have a little matching game planned for us before I talk about the design process, particularly in relation to when we're building our rocket. So what we're going to do, and if you're on the Nearpod, awesome. If you're not, that's okay. Just hang tight for 1 minute and 45 seconds. I want you guys just to kind of match the step in the design process to the correct definition. So it sounds like most of us know what the design process is, so this should be pretty straightforward. Go ahead and take 1.5 minutes. I'm glad that Noah thinks that it's easy. I see it. Somebody has already finished, so nice job. Go ahead and take about 1 more minute. And in the meantime, if you are on a desktop and you have a chance to log into the Nearpod, I'm going to drop the code for everybody one more time, because I know I got started before everybody joined in. Nice job. Thing that I love about Nearpod is that I can see everybody's responses. You have about 30 seconds remaining. All right, and that's our time. Let me take a look. I think almost everybody got to finish, so very nice job. All right, so now let's quickly talk about it. I see we have some experts, so I might lean on you guys to answer here in the chat. So let's talk about the steps of the design process. So just want to quickly say that this isn't necessarily when an engineer is doing any project. This isn't necessarily like they're sitting down, they're like, oh, okay, let me go through each step of the process to make my project. It's more of a way of thinking for engineers. And so that's why I wanted to kind of, it sounds like most of you are familiar with it, but that's why I wanted to practice it today, right? It's a thought process that engineers are constantly adopting in order to solve any problem and practice those critical thinking skills and problem solving skills that you thought were so important. So what you'll see here, and these are just a couple pictures to represent the different steps. So the first step of the design process is empathizing. And so empathizing is basically being able to, engage with people and understand people, specifically to understand, what is something they want, what is something they are desiring and need a design for, right? And who wants it and why do they want it? Really understanding the thought process behind things that we need in society that may not exist. When you're defining something, so then engineers are like, okay, this is what somebody wants. Somebody wants a rocket ship to go into space as simply as buying a ticket and being able to do it for fun, right? And so when you're defining something, this is really when you're kind of narrowing everything that somebody would want about a particular problem into then defining it as a particular problem in one sentence, right? So being able to understand then the problem from a variety of angles and viewpoints, and specifically, why is this a problem? And so if we're thinking about our rocket ship and we're taking this engineering design process through the steps of building the rocket ship for SpaceX to get humans to space by 2024, right? So the empathize part is getting humans to space. The defining part, so we need to think about the problems. So in the chat, what problems might humans face or humans and scientists and engineers face in getting humans to space by 2024? What are some problems that we might face? Gravity, yeah, most definitely. Money, so being able to fund a lot of spaceships because they are very expensive. So the actual manufacturing, so I see a faulty engine, that's really great. So actually manufacturing the rockets, ensuring that it's secure and created safely, people actually wanting to go to space, people willing to take on the task. So who's gonna actually be the first humans to go into space? Well, we have astronauts already, but I mean, as civilians, right? Awesome. So yeah, these are great problems. And so specifically, let's focus on the problem of building the simple and safe rocket, right? So we need to figure out how we can build a rocket that's not only just simple because we don't have all that much money, and rockets are very expensive, but they're also safe for civilians who would be going into space basically for fun. And so once kind of engineers go through empathizing and defining the problem, then they need to go through this ideate step. And whenever they're kind of going through this step of the process, they're really thinking about, okay, so I know what the problem is now, but how do I fix the problem? what solutions or systems or steps can I put in place to help fix this problem? And this is kind of a brainstorming phase. And in a second, I'm going to ask your support in brainstorming around how we can fix the problem of building a safe, simple rocket for civilians to go into space by 2024. Okay, so hang tight. But before I go into that, I wanted to quickly go over the last two steps here of the engineering design process before we actually go through them together. So after scientists and engineers go through the idea phase where they're brainstorming the best way to fix the problem and coming up with a solution, then they're going into the prototyping where they're actually building an experimental model of this solution. And so this can include the coding portion, this includes the manufacturing portion, and this includes like the building of the physical concepts. So for us, it'd be building the physical rocket. And then at the end, they're kind of testing everything out. So during the testing phase, they're always asking themselves, did this solution actually solve my original problem? Is it the most efficient solution to the problem, or could I tweak it and make it better? And so that's why there's this arrow here, because oftentimes engineers have to go back to the idea phase to really come up with a better solution, or maybe make a couple tweaks to make it the best and most efficient solution for the civilians. And so when we're talking about people's lives here, right, going into space, we need to make sure that we're testing it out very carefully and ensuring that the rocket ship is safe and secure. All right. So any questions about specifically the design process before we jump into actually fulfilling the design process for our rocket today? So I see a question in the chat. Could it be possible if they forget a step? So I think that, yes, sorry guys, sometimes my screen will flash on and on. That's not on your side, that's on my side. My camera gets a little glitchy. But sometimes, you know, engineers might kind of combine these steps into a combined step. They're never skipping one of these steps because it's just a kind of a thought process that they're always going through. But sometimes you may see that they'll put kind of the empathize and the define into one, because they understand they're talking to somebody and somebody brings up a problem and they're already thinking about that problem and defining it, right? Good question. All right, so then let's jump into going through the design process for our rocket and our problem of building a safe and simple rocket for 2024 so that everybody can go into space. Before we do that, and before we go into the ideate together and go through a brainstorm, I wanted to quickly take you through a little tour of SAM Space. And I know that some of you have gotten a chance to download it, which is great. If you haven't, that's okay. I'm going to share my screen. But if you do have SAM Space, go ahead and take a minute to get that open so that you can explore it with me. And I'm going to share my screen. And so we're going to jump into thinking specifically about, you know, when we're thinking about software, and this is our software at SAM Labs. It's very visual based. It's very picture based. And this is what the workspace looks like when you start a new project. So can everybody see my screen? All right, great. So I wanted to quickly take you through a little overview of what SAM Space looks like and kind of how it's teaching the basics of coding any systems. And so in the top right-hand corner, the most important thing for you guys, because you don't have these Bluetooth blocks, I want to make sure that you can still build the code along with me. And so at SAM Labs, we actually are able to build different systems with Bluetooth blocks like motors, lights, light sensors, buttons, buzzers, and all these different blocks here. But you can build it along with me with your virtual blocks. And so I'm going to show you how to turn the virtual blocks on. Go into the top right-hand corner, and this toggle here is the settings toggle. And oops, you're going to want to make sure that the show virtual blocks is toggled to blue, because that means that they will be on. You'll also want to make sure that your group behaviors is on, because that's important when we're thinking about how to manipulate different systems in different ways. And so once that's on, you're going to see all these different blocks down here. And so down here is kind of different tabs that'll take you through how to build systems. So every system has various inputs and outputs and then ways of manipulating the system. And I'm going to give you an example here. And so when we look at these inputs, these are kind of blocks that actually receive and collect information. So these are things like a key press, like the key press space bar on your keyboard. Buttons are an example of inputs, right? You're actually pressing the button down to start something. Light sensor, a slider, so you're actually moving something to start a system. A pressure sensor, so for example, if you were to stand on something, it would start a system. Proximity sensor, so how close you get to something. Heat sensor, and a dimmer. So all of these blocks are kind of designed to start a system. And so if we think about turning on a light when we walk into our room, right? We actually flip the switch. That's the input, is actually flipping the switch itself. And then the output is that the light will actually shine. So when we look at the outputs within Sam Space and the blocks, outputs are basically blocks that kind of do something with the information in different ways. That might be with light, that might be with sound, that might be with movement. And so some of the outputs we have are like a camera, sound player, that's, you can, we're gonna explore this later, but it's different sounds. RGB LED, that's a fancy way of just saying red, green, blue light. DC motor is the actual movement of motors. A buzzer, and servo motors, and the vibration motor. And then you'll see the behaviors. And this is where it gets fun, because behaviors allow us to manipulate systems and according to kind of what the problem is and the solution we're trying to come up with, right? And so if we think about the light switch example, the input is flickering the light switch to turn it on. The output is the light. We could manipulate our system by maybe putting a piece of blue kind of paper over my light, and I could change the color of my light. And so that's similar to what behaviors do, right? They're kind of changing and manipulating the system to make it more unique and specific. And so if you go into the different categories within the behaviors, there's tons of different blocks that you can actually drag in to manipulate systems and build with them. So different things you can do within the sound, motion, colors, and then some logic as well, which gets into that problem solving and critical thinking skills. So that's a little basic overview of Sam Space. So I just wanted to give you a little overview before we started to build within Sam Space. Everybody good? Everybody still see my screen? All right, I got a couple yaps. So if you can't, okay, makes sense. Awesome. If you can't find anything or you don't have the Sam Space open, no worries. I'll make sure to keep sharing my screen so that you can see it. So let's go back to, I'm going to skip this quiz just for the sake of time. Let's go back to this ideate phase, and we're kind of brainstorming ideas of solving our problem. So who can remind me of what our problem is? We've defined it. So we're thinking about SpaceX, we're thinking about rockets. So we brainstormed a lot of different problems that SpaceX might face when trying to get civilians into space by 2024, but we're specifically focusing on building a simple and safe rocket, okay? So we need to think about all the different aspects that go into building a simple and safe rocket. And so here's a little brainstorm that I came up with. And so in the Nearpod, hopefully you can see that. I'm gonna share the Nearpod out real quick if you're not logged in, just so everybody sees. And so these are some things that I want you all to think about as we start to build our code. So what starts a rocket ship? You know, like what physical components, what inputs start a rocket ship? What controls the movement of a rocket ship? What outputs occur when a rocket takes off? So when the astronauts actually, you know, blast off, what happens? What's the output? Is it sound? Is it light? Is it movement? Is it motion? And then what virtual or physical blocks may you use within Sam Space that I just showed you to build that code? All right, so keep those questions in mind as I walk you through building within the code within Sam Space. All right, you guys ready to code? I'm gonna take that as a yes. All right, I see a couple yeses. Awesome. So let me make sure to share my Sam Space again with you. All right. So if we think about the launch of a rocket ship, right? There's usually a big countdown, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and blast off. So what actually starts the system for a rocket to blast off? And if we look at our inputs here, what input should we use to simulate this rocket ship blast off? You think we should use a button, a light sensor? Is it dependent on light? Is it dependent on moving a slider? Is it dependent on pressure, so actually pushing down on something? Yeah, I like it. I see it. I see it. Buttons. So we're going to actually use a button. Nice job. So here's what we're going to do. We're going to drag and drop this button to the left-hand side of our screen. All right. So the buttons input are in our system. It's going to start our rocket ship before it blasts off. All right, now we need to think, okay, what's the output of our system, right? What's gonna actually happen once somebody presses the button? Is it if the astronaut's pressing the button or somebody in mission control? You know, what's gonna happen as an output? So let's go to our output category. What blocks do you think I should pair from my kit here as the output for my rocket? So I'll hold it up so that you can see. So these are our Bluetooth blocks, and I'm actually going to pair them so that you can see everything come to life, but you can still build the code with me, no worries. So I see these are our motors. Do we think that rockets have motors? Is there movement within a rocket when the system starts? Yeah, definitely. We're going to kind of put the light sensor to the side because our input is a button. And we're going to put the RGB LED to the side, and we're going to focus on movement because we're trying to make our rocket blast off simply and safely. All right, so here's what I'm going to do. Quickly, I'm going to show you how we can pair these Bluetooth blocks. So you're going to hold it in for 2 seconds, and you'll see that it turned red. That means that it's ready to pair. And if you go to the left-hand corner here in the connect, you'll be able to directly pair this DC motor. And when you press the check mark, you'll notice it turns white, and that means that it's paired to your app. All right, so now I'm going to pair this piece of hardware. Same DC, it's different DC motor, but the same block here, and it's paired. And so now you'll see they actually pop up, and they look a little bit different than the virtual block over here. These are kind of shaded in. And as you said, these are going to be the output of my rocket. So I'm going to drag them to the right-hand side of my screen. And so it's really important when we're building this code, guys, that the left-hand side is always the inputs and the right-hand side is the outputs, because just like we read from left to right, we're going to write our code from left to right. All right, and so the next step here is to connect our button to our motors. So everybody go ahead and do that on your app if you're following along. And I'm going to hold up the motors so that you can see what happens. So when you make the connections, you'll notice that when I press the button down, and to press the button down, you're going to hold this larger circle above it. What do you guys notice? And so you can see it on the screen. Can everybody see the axle spinning around? And you can also, I'm going to hold up closely, you can also see the axle on my actual Bluetooth block spinning around. So it's directly taking information from me holding the button down and making my motor move. Nice, nice job. So I see some questions about Sam Space. If you weren't able to download it, that's okay, no worries. If you don't have the blocks, that's okay too. You can build the same system with the virtual blocks. So you would drag these DC motors onto your system, and I'll drag another one there so you can see, it's still simulating the same movement. So even though I have the real Bluetooth blocks, you guys can still build the code along with me. All right, awesome. So this is kind of the basic part of my rocket ship, right? So the button starts my system, and the movement is the output. But we need to specifically think about simulating a rocket launch in the most accurate manner. So if we think about astronauts in the rocket ship, are astronauts constantly holding a button down in order to make the rocket kind of move and launch into space? Exactly. No. So we need to think about a behavior that we can add into the system to ensure that when we press the button, it simulates like a real rocket launch. Like astronauts would press the button at blastoff, and then the rocket would continue to move into space. So what we're going to do is we're going to actually remove the connections here. And we're going to look at these behaviors. So what category do you think we might go to if we're thinking about keeping a system on? So would that be numbers? Would that be colors? Would that be switches if we're trying to keep a system on? So I see a couple guesses here. I see time, I see switches. I see switches, I see switches. Awesome. So the correct category we're going to go to is switches, because switches will allow us, similar to a light switch, to flick it on. And we don't have to hold a button to keep our light on all the time, right? But we flick it on and it stays on until we flick it off, and then the light goes off. All right, so let's go to switches. And if you actually click on these blocks, you can explore and see a little definition of what each block does. So if you guys are exploring Sam Space afterwards, that's really helpful. But specifically, we want our rocket ship to be turned on with the press of a button and to stay on. So we're actually going to drag a toggle into the system. All right. So now we have a behavior in the system, and let's make our connection. So we're going to drag the small circle to the first small circle, so the input to the toggle. And then now your toggle is going to control your two DC motors. So drag from the toggle to your first motor and the toggle to your second motor. All right. And so now let's test the system out. And I'm going to go here because we're still building the prototype. And I'm going to press my button. Let me hold up my blocks for you so that you can see. Press my button. And what do you guys notice? Pressed it off. Press the button again. And hopefully you can see with the real Bluetooth blocks, but then also on the screen, yeah, exactly. It's moving and it's staying on, right? And that's really why the continuous movement exactly is important with this toggle. And when I press again, that system turns off. All right, so this is a more accurate representation. We just problem solved to figure out how we can accurately simulate a rocket launch and the movement kind of proceeding and being a continuous source of movement. So that's the first step here to building our prototype. We built the code for our rocket. Pretty basic, but now let's take it a step further. So who was able to get some paper and some tape to build their physical prototype? Okay, no worries if you didn't, but I'm going to kind of walk you through how to build the physical prototype of your little rocket. So here's what we're going to do. If you do have the paper, go ahead and grab it right now. And let me know when you're ready. I'm going to move forward without anybody. All right. So basically, you can take a piece of paper, printer paper, construction paper, whatever you have. We're going to take that piece of paper and we're going to fold it into fourths. So we're going to fold it in half first. Okay, I mean, I don't know what your teachers call it. I call this hamburger style. Then you're going to fold it in fourths. So you're going to fold it in half again. And it should be like a nice little square. Okay, so that was to make some even kind of distributions. And we're going to open it up now. And we're going to cut out a 1/4 of this. So just one of the little squares here. All right, and it just looks like this. Okay, if you're building, let me know if I'm moving too fast. I don't want to leave anybody behind. Okay, so we're going to now take this little square, and one of the materials that we asked was for a straw, and you're going to see in a second why we use a straw. But for right now, before we actually use the straw, if you have tape, make sure you cut pieces of tape. Make sure you cut pieces of tape because we're going to roll it so that we can tape everything together. So I'm going to now take my piece of paper and roll it around my straw to kind of, not too tightly, but tight enough to keep a nice roll here. And so I'm just going to carefully roll it around. I see the comments about it being plastic. No worries, it's actually a reusable straw. Okay, so we have a roll here, our rolled up paper, and this is going to be the body of our rocket. And now I want you to tape it all together. So we're going to just put a couple pieces of tape on it to hold the body of our rocket and the prototype together. Right? So engineers are constantly building prototypes. Some prototypes are actually as simple as the one that we're building right now, just to test the design. You know, obviously they get way more complex as they go on and they're actually manufacturing and building model rockets, but this is our little prototype for today. All right, so here's the body of the body tube of my rocket. And now we need to make sure to kind of show the nose of the rocket. So on the top part here of my rocket, I'm gonna actually just pinch together the portion. And I'm gonna tape it to make the nose of my rocket ship. Like that. And the last step here is that I need the fins. And so the fins, does anybody know why the fins are important for a rocket? So it can fly. How could, if the fins, yeah, I see a comment there for steering, right? So the fins will actually help the rocket kind of go in specific directions, kind of when they're launched. So we want to make sure that we make some fins here. And just for the sake of time, to make the fins, you can follow the steps here, and I can share these slides with you guys later if you would like. But I actually have a rocket already made, so I'm just going to fast forward so that we have enough time. All right. So here's the little rocket, and here are the fins. Here's the nose, and then here's the body tube. Now, you may be saying, okay, Mackenzie, where does the straw come into play, right? And so even though you guys may not have the physical Bluetooth blocks, later on, I'm going to challenge you to use a straw to do a little rocket launch of your own. So I'm going to put that to the side for right now. And we're going to go back to our code here. So when engineers are going through the entire prototyping process, they're usually writing code, going through the design process, and then also building the physical prototype, just like I did with my little rocket here. And so we're going to put those two pieces together. So now I'm going to kind of use the code that I just built with the button and the two DC motors, and I'm going to apply and put my rocket onto a little system to model a little rocket launch. So to do that, I'm going to walk you through. So in the kit, there's this little yellow chassis. And what we're going to do is we're going to build, it's going to kind of look like a car, but remember, we are modeling the simulation of a rocket here. And so I'm going to take the chassis, I'm going to put my motors into the chassis. So you'll see here, there's these little crosses here, and that's where your motor is going to slip in. And these are rubber, so they're pretty durable whenever you're kind of putting them in to this chassis. And all of the blocks are Lego, have a Lego adapter. And so if I had Legos around the house, I could kind of design my own little rocket with the Legos and then put it on top of my chassis to make like a more advanced prototype rather than just paper. And so if any of you have Legos, I would challenge you to do that. And then I'm gonna put the second motor in like that. And then I'm going to attach the wheels to the axles of my motors. And so the wheels will have a flat part on them, and I'm going to align the flat part of my axle, just like that. And then the other wheel will attach to the other axle, just like that. All right. And so pretty simple system here. And I'm going to actually put this roller ball in the bottom so that it moves around nicely. And you'll notice, and I'm just going to show you this because I think this is a pretty cool feature after we put the Bluetooth blocks together. And I'm going to test my code before I attach my rocket. And so I'm going to adjust my screen here so you guys can see. Okay. And I'm going to press the button and let's test this out. So you'll notice that the system, well, my wheel flew off because I hit my headphone, sorry. But you'll notice that the system is functioning, the motors are moving, and my wheels are turning. Does anybody know why it's spinning in a circle? Specifically, at what point is my system malfunctioning? Why is it spinning in a circle? Do we think that it's the button? Do we think that it's the toggle? Do we think that it's the motors? Yeah, so somebody mentioned the wheel. Yeah, so specifically it's the output of our system. So we want to make sure that we go in and we kind of debug or fix this because it's not working how I thought. So if we go into the settings toggle, you can manipulate different settings within the motor. So you could change the speed to how fast it goes. I'm going to make it about 50 of speed, so that's not going super quickly. And then I'm going to also change the direction because when it was spinning in a circle, it looked like it wasn't going forwards, and I want to go forwards. All right, so I changed something, so let me test it out. Before I do that, I need to make sure that the other motor is matched in speed. So I'm going to set them both to 50. Okay. And so I'm going to show you so you can see. And I'm going to start my system in 3, 2, 1. Uh-oh. And you'll notice it's going backwards. So I did not debug it correctly. So I got to go back into the settings here. And I'm actually going to go clockwise. And I'm going to change this setting to counterclockwise. I'm just messing with the direction of the motor and the wheels. So let's see that if it works now. Good. Going to start it in 3, 2, 1. And you'll notice that my car is moving in the right direction. Awesome. All right, so that's the little car model. Now, I know some of you may have explored that before. So now let's kind of apply it to our rocket. So here's my little rocket, and all I'm going to do is I'm going to tape my rocket to the chassis, just like that. And you can imagine how now when I press my button and I go 3, 2, 1, take off, how this is a similar system, just rockets are actually moving vertically rather than horizontally like a car. And so it's still simulating the movement and the constant movement to make the rocket go into space. Cool, right? Seeing some cools. I love it. I love it. All right. So you guys ready to, for the last couple of minutes, have a little challenge? A little coding challenge? All right. So let's take this kind of code and our prototype a step further here. And specifically, if we think back to the problem we were trying to solve as a SpaceX engineer, we want the astronauts and the people and the civilians to take off in a safe and simple manner, right? And so really, right now, do the astronauts or the civilians know when the blast off is going to occur? No, we don't know yet. And so that's why we need to code a system. When you watch the SpaceX launch, those of you that did do you remember hearing the countdown? And with any rocket launch that you've ever watched, there's always a countdown where the person in mission control is counting down, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off, right? And that's how the astronauts know that it's takeoff time. So with that being said, that's going to be our first challenge here. So yeah, similar to New Year's, I'm going to challenge you to go into the Sam Space app, and I want you to see if you can code a system to simulate the countdown and the blast off of your rocket ship. Okay, so if you don't have it, that's okay. So Nala, here's what I'm going to do. I'm going to give you control of my screen while everybody else, if they do have the app, can explore it. But what we're going to specifically think about is what blocks would we use to simulate a countdown, and what outputs and behaviors are needed. So specifically, when we're thinking about this, we're thinking about, when we have a countdown, is that an output of light? Is that an output of sound? Is that an output of movement? So when we go to our outputs, what block do you think I should drag? Or I'm actually going to pass it over to Nala. Did I say it correctly that time? Okay, good. So let me see. Oh, I think since I'm sorry guys, since I didn't actually start this Zoom, I don't have control over that. All right, so Nala, do you want to tell me what output block I would use to simulate the countdown for our rocket launch? Would it be a camera? Would it be a light, an LED, a buzzer, a sound player? Yes, I'll repeat the question. So when we're thinking about the simulating the countdown and the blast off of the rocket ship, what block would we use as the output for a countdown? So if we're thinking about the 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, is that an output of light? Somebody actually flashing a light? Is somebody moving something, or is somebody giving off a sound? Yeah, good, sound. So we're actually going to drag the sound player here. And the sound player is a really cool block. I definitely encourage you guys to explore it. There's tons of different sounds here. And if you go into the features, into the settings here, you can go to different categories of sound. All right. And so there's different like home sounds. You can build different systems. There's even a toilet flush. I know the kids love that. There's different emotions, sounds. There's actually different music notes. So like a drum sound, guitar sounds. But specifically, we're looking for a countdown. So what category might we find a countdown in? No, we don't want the toilet. Yeah, we're trying to simulate the countdown for our rocket launch. So, and those of you that are exploring, I'm going to challenge you to think about what category we might go into. Okay, let's see sound effects. So I see booing, car rev, cash register, foghorn, rejection buzzer, school bell, success sting. Okay, not there. Let's try FX2. Yep. Laughter, whoosh, submarine, siren. So it's not there. I'm going to give you guys a hint. Let's look in the games. And specifically, 5, 4, 3, 2, 1, go. Okay, so let's test it out. And let's see if it simulates as accurately as possible this rocket launch, okay? So let me zoom out here. And you guys feel free to count down with me. See, Elizabeth already is. I love it. And I'm going to actually drag and drop this. Or I'm sorry, I have to move this around a little bit. So specifically, I'm going to want to make sure that my countdown happens before the blast off, right? So in order to do that, before I actually make my movement for my rocket blast off, I'm going to need to add another block in here. And so I know we're running short on time, so I'm quickly going to show you. We're going to add a delay block into the portion of our code specifically made for our rocket launch, right? Because we don't want the rocket to launch until after the countdown. And then I'm also going to add a toggle into before my countdown just to make sure that my countdown stays on when I press my button. Okay? So let's test it out. And I'm actually going to move my head so you can hear it. And I'm going to press the button and let's test it. All right, so I just fixed, my wheel flew off, but everything ran pretty smoothly. Sounds like an accurate countdown to me. How about to you guys? Great. And so one thing that I did notice was that my rocket ship motors actually took off before the countdown was over. So I would have to go in, and I did plan for this time. I know that we're running a little short on time, and I am going to make sure that my delay is for those 5 seconds so that the astronauts know to wait for the countdown, 5, 4, 3, 2, 1, before the blast off. So let's try it one more time. And now hold my rocket ship up so that you can see it, and let's test it out. Here we go. 3, 2, 1. And my rocket would be blasting off, and you can see the movement just like that. Whoops. Awesome. So I've accidentally started again. And so that's our little system for our rocket launch. And you'll see here that I added another sound player, and I actually added the crowd cheering. So that's what that second sound player is. And I just thought that it was pretty creative. So I know some of you were like, well, Miss Mackenzie, what is this straw for? So here's what I'm going to leave you with, guys, in this last 30 seconds is I want you to now, go through the steps to build your own little rocket. And I want you to use your straw to ensure that the rocket lands on an accurate target. And so over the weekend and when you have time, I want you to make your own little target. And using your straw and target, see if you can accurately land your rocket on the target. All right, so that's your challenge that I'm leaving you with. And you will need to think about the different variables that you'll need to change in order to land it accurately, and actually make your rocket, because I know some of you didn't get to do that either, which is fine. But I'm going to challenge you to give it a try. Sound good? All right, great. Yeah, and so I would just cut a piece of paper into a circle, and that could be your target. Because if we're thinking back to that problem as engineers, we wanted to design a rocket that is safe and simple for the civilians to go into space, right? And so a part of the safety is not only takeoff, but actually landing it accurately as well. We don't want to land our rocket ship in the ocean. We'd want to land it on, like, for example, the SpaceX pad. And so that's what I'm going to leave you guys with, is to test that out. Try to build your own little rocket and straw launcher, and have fun with that over the weekend. All right. And if you do want to tag us at Sam Labs, I would love to see your creations. You guys were a great crew. Thank you so much for joining in. Have a good weekend and stay safe.
Hey guys, did you guys enjoy Mackenzie and Sam Labs? I know that's a yes. We just want to say thank you so much, Mackenzie. Thank you, Sam Labs. Again, Mackenzie Mixter is she's the education consultant for Sam Labs, and just a wonderful, wonderful teaching educational tool. And we want to say thanks for taking your time out and agreeing to come out here. And basically, you're rounding out our month. We've been doing all kinds of different workshops and things for this month. And thanks for being, the kind of closing the door in a beautiful educational way. So, we've built this wonderful audience with you guys over the last couple of months. We're getting ready to look at opening our spaces back up again in our libraries in Miami. So we're looking to figure out how if we're gonna continue with our virtual classes, or if we're gonna start doing some stuff inside of our spaces. So, we're not sure, but you guys stay tuned. We built this great audience with you. We don't want to lose you. So we'll stay in touch with you and let you know what's coming up in the future, in the near future for July. But again, Mackenzie, you're awesome. That was really great.
Awesome. Thank you, guys. I had so much fun.
Fantastic. Well, we'll see you next time. Yeah, Hector, you want to say anything?
No, it was a really great demonstration. And we were able to see how the whole process works from beginning to end. So thank you so much for the demonstration.
Awesome. Thanks, Hector. Yeah, if you have any other questions, I can definitely pass along my email. And if you have any questions when building anything, let me know.
Cool. Yeah, Hector is one of our staff. If any of our UMake and Technobus staff are on, go ahead and turn on your cameras and let's say thank you. We have got Ashley there, and you saw Hector. I think Jaden and Dinah are here. So those are some of our instructors and people who work inside of our maker spaces and our Technobus. Actually, the Technobus is right there behind me. You can see the really beautiful vehicle that we travel around Miami-Dade County teaching, SAM labs and Tinker and coding and drones and 3D printing and music, photography, filmmaking, all kind of stuff.
So cool.
Yeah.
You guys are doing really great stuff down there. I love it.
Thank you.
Yeah, definitely. And next time I'm down in Florida, I might have to come over and visit the Technobus.
Most definitely. The invitation's always open.
All right. Awesome. Well, thank you guys so much. Thank you for having me, Marlon. I really appreciated it. It was great.
My pleasure. Our pleasure. So guys, look for the video. We're going to send that to you via email. You can always go to our UMake Miami and just look that up. Follow us on our social media pages. This is what we're called, in case you don't know, UMake Miami. Just check us out and stay tuned to your email, and we'll make sure that we follow up with the video of this wonderful presentation from MACKENZIE and SAM Labs. All right. Bless you guys. Stay safe.
Thank you guys so much.
Have a great weekend, guys.
Bye-bye, everybody. Thank you.
Bye.
Bye, everyone.
Bye.
Bye.